Previous class, we discussed about the performance characteristics of the DC generator. In this lecture, we will study about what is metadyne, what is amplidyne, introduction of permanent magnet, DC motor, and its classification, application, advantages and disadvantages. Next, we will move on the introduction of brushless DC motor, types of brushless DC motor or the classification of that motor, advantages, disadvantages, and the application of brushless DC motor. And finally, the references of this presentation. So today we cover all these topics in this presentation. Let's start with topic 1. What is metadyne? So metadyne is a special machine which consists of two pair of brushes or has an additional set of brushes on the D-axis. This arrangement enables the armature MMF to provide most of the excitation and achieve higher power gain. In this, the brush of the quadrature axis, Q axis, are short circuited and direct axis means D axis brush give the output. So the systematic diagram of metadyne is shown in a figure. In this diagram, there is two winding, one is called the armature and another is called the field winding. FF is called the field flux of field winding. VF is called the voltage applied to the field winding. IF is called the current to the field winding. You can see the diagram. There is an extra number of brush pair connected to Q axis. तो आर्मेचर रिएक्शन में या जो हम आर्मेचर में है वो दो ब्रश के साथ दो ब्रश हम और लगा देते हैं, तो ऐसे अरेंजमेंट से जो मशीन बनती है इसको हम मेटाडाइन बोलते हैं. तो इसमें हमारे पास दो करंट रहेंगी, एक ID इज कॉल्ड द डायरेक्ट एक्सिस करंट और दूसरा रहेगा IQ मींस क्वाड्रेचर एक्सिस करंट. सो मेटाडाइन कुछ भी नहीं होता है, बस इसमें हमारा जो डीसी मशीन है उसी में अगर हम एक्स्ट्रा पेयर ऑफ ब्रश लगा देते हैं जिससे हमारा दो एक्सिस क्रिएट हो जाते हैं, एक डायरेक्ट एक्सिस और दूसरा क्वाड्रेचर एक्सिस. तो इस अरेंजमेंट को हम बोलते हैं मेटाडाइन. Stator of machine has controlled field winding. The current if flow through the control field winding. The generator is rotating at a constant speed and EMF EAQ is induced between the quadrature axis brushes QQ dash because of the control field winding MMF. This EMF is given by the equation so below. EAQ is equal to KAF into IF, where KAF is called the constant and IF is called the field current. Where KAF is a constant and IF is called the field current. Okay. So the brushes QQ dash are short circuited. A quadrature axis armature current IQ flow and establish an EMF FQ if the quadrature axis. Since the impedance of the short circuit path is low, a small change in control field current produce a greater armature current in the Q axis. The magnetic field is stationary in space because of the commutator action. rotation in the q-axis flux produces an EMF in the armature. This EMF appears across the direct axis brushes d dash. So in our previous diagram, and is given by the equation EAD is equal to KDQ into IQ, where KDQ is a constant and IQ is the quadrature axis armature current. If the load resistance RL is connected across the direct axis brush, the direct axis armature current ID will flow through the load. The direct axis flux FD is produced by this current, and according to the Lenz law, it opposes its main cause, that is the controlled field MMF FF. The magnetic field of the current produced is 90 degrees ahead of the flux wave producing the voltage. Since there are two stages of the voltage generation, the MMF of the direct axis output current is shifted twice by 90 degrees. As a result, it opposes the controlled field MMF. The voltage generated in the quadrature axis is EAQ is equal to KQF into IF minus of KQD into ID. This is equation number 3, where KQD is a constant if the magnetic saturation is neglected and speed is assumed to be constant. And increasing in ID means direct axis current decrease EAQ, and as a result IQ is reduced. Hence EAD and ID are reduced. Thus, over a wide range of the load variation, the value of field excitation current IF and the output current ID remain constant. A metadyne acts as a constant current generator. So this is a simple definition of the metadyne. It is act just like as a constant current generator. So this is all about the metadyne. Now we will move to the next topic. Name is amplidyne. Amplidyne is the most common version of the metadyne. It consists of the basic metadyne in which a compensating winding is connected in series with the power output brush terminal. The compensating winding cancel out the D-axis MMF, which oppose the controlled field MMF. This is a systematic diagram of amplidyne. Difference of the metadyne and amplidyne only is that of the compensating winding. मेटाडाइन में हम कंपनसेटिंग वाइंडिंग नहीं लगाते हैं और एम्प्लीडाइन बनाने के लिए हम कंपनसेटिंग वाइंडिंग को कनेक्ट कर देते हैं डी एक्सिस के साथ सीरीज में. So the compensating winding is located in the direct axis or D axis on the stator. This compensating winding carries the load current ID. The winding produces a flux which opposes the flux produced by the direct axis armature current. The effect of the negative feedback of the load current is minimized. The D-axis flux now depends on the field winding current. The degree of commutation C is defined as the ratio of effective compensating winding turns to the effective armature turns. तो इन दोनों टर्न्स के थ्रू हम कंपनसेशन या डिग्री ऑफ कंपनसेशन को डिफाइन आसानी से कर सकते हैं. This is the formula. C is equal to effective compensating winding turns divided by effective armature turns. The effect of degree of compensation on the load characteristics of a cross-field machine is shown below. So this is the characteristics. In this diagram showing the three different value of the degree of compensation, means C greater than to 1, C equal to 1, or C not equal to, or sorry, C equal to 0. So these three characteristics is plotted between the output current IT and the terminal voltage EAD. In case of betadine, there is no compensating winding, thus the value of C is equal to 0. In case amplidine, full compensation exists and hence C is equal to 1. The terminal voltage of an amplidine is considered almost constant. The power amplification is of the order of 105 as compared to 100 for a direct current generator. A series connected quadrature axis winding is placed on stator of the amplidine to improve its performance, and as a result quadrature axis commutation also improve. They were used before the origin of high power, high speed of response of solid state power amplifier and control equipment. They were used to supply DC power to process control motor, excitation system of large AC generator, and walled neodot speed control system. They are now replaced by the solid state power amplifier. So this is all about the amplidine. Next topic is permanent magnet DC motor. A DC motor whose poles are made of permanent magnet is known as the permanent magnet DC motor. बहुत ही सिंपल है, ऐसी मोटर जिसके हम पोल्स परमानेंट मैग्नेट के बनाते हैं. नॉर्मली हम इलेक्ट्रोमैग्नेट के पोल्स बनाते हैं, लेकिन अगर हम परमानेंट मैग्नेट्स के पोल बनाएंगे तो उस मशीन को हम बोल देंगे परमानेंट मैग्नेट डीसी मोटर. दिस इज द डायग्राम ऑफ परमानेंट मैग्नेट डीसी मोटर. The magnets are radially magnetized and are mounted on the inner periphery of the cylindrical steel stator. The stator of the motor serves as a return path for magnetic flux. The rotor has a DC armature with commutator segment and brushes. The cross-sectional view of two-pole permanent magnet DC motor is shown in a figure. The permanent magnet DC motor generally operated on 6 volt, 12 volt or 24 volts DC supply obtained from the batteries or rectifiers. The interaction between the axial current carrying rotor conductor and the magnetic flux produced by the permanent magnet result in the generation of the torque. The circuit diagram of permanent magnet DC motor is shown below. Here IA is called the armature current, V is called the supply voltage, RA is called the armature resistance, and E is called the induced EMF. In conventional DC motor, the generated or back EMF is given by the equation E is equal to K into phi N or phi NZ P divided by 60 into A. तो बाकी चीज़ों को हमने फाई और एन को छोड़ के बाकी चीज़ों को हमने कांस्टेंट के से रिप्लेस कर दिया है. सो ई इज इक्वल टू के फाई एन. दिस इज इक्वेशन नंबर 1. द इलेक्ट्रोमैग्नेटिक टॉर्क इज गिवन एज TE is equal to K phi into IA, where phi is called the flux, IA is called the armature current, and K is called the constant. In permanent magnet DC motor, the value of flux phi is constant. Therefore, the equation number 1 and equation 2 become A is equal to K1 into M and Te is equal to K1 into Ia because phi is constant. Considering the above circuit diagram, the following equations are expressed. So V is equal to E plus Ia into Ra, where V is called the terminal voltage, E is called the induced voltage, Ia is called the armature current, and Ra is called the armature resistance. Putting the value of E from the equation number 3 and equation number 5, we get V is equal to K1 into N plus Ia into Ra, or we can write as a N is equal to V minus Ia into Ra divided by K1 in equation number 6. Where K1 is equal to K into phi, N is known as speed voltage constant or torque constant. Its value depends upon the number of field poles and the armature conductors. The speed control of permanent magnet DC motor can be controlled by using the flux control method. As the flux remain constant in this type of motor, both speed and torque can be controlled by armature voltage control, armature rheostat control, and chopper control method. These motors are used where the motor speed below the base speed is required, as they cannot operate it above the base speed. The next topic is type of permanent magnet material. There are three types of permanent magnet material used in permanent magnet DC motor. The detailed information is given below. Alnicus. Alnicus has a low corrosive magnetizing intensity and high residual flux density. Hence, it is used where low current and high voltage is required. Faraday. They are used in cost-sensitive applications such as air conditioner, compressor, and refrigerator. Rare earths. Rare earth magnets are made of samarium, cobalt, neodymium iron boron, and they have a high residual flux and high corrosive magnetizing intensity. The rare earth magnets are exempt from demagnetizing problem due to armature reaction. It is an expensive material. The neodymium iron boron is cheaper as compared to samarium cobalt, but it can withstand higher temperature. Rare earth magnets are used for size-sensitive applications. They are used in automobiles, servo-industrial drives, and in a large industrial motors. The application of permanent magnet DC motor. The permanent magnets motors are used in a various applications. They are developed up to about 200 kilowatt for the use in various industry. The following applications are given below. The permanent magnet DC motors are mainly used in automobiles to operate windshield wipers and washer, to raise the lower windows, to drive blowers for heaters and air conditioner, etc. They are also used in a computer drivers. These type of the motor are also used in a toy industries. Permanent magnet DC motor are used in electronic toothbrushes, portable vacuum cleaner, and food mixtures. This is also used in a portable electric tools such as drilling machines, hedge trimmers, etc. So there is a following advantage of permanent magnet DC motor. They are smaller in size. For smaller rating permanent magnet, reduce the manufacturing cost, and thus permanent magnet DC motor are cheaper. As these motors do not require field winding, they do not have field circuit copper losses. This increases their efficiency because inside the electromagnetic field in this machine we will use the permanent magnet for the field circuit. Now there are some disadvantages or drawback of permanent magnet DC motor. Permanent magnet cannot produce a high flux density as externally supplied shunt field does. Therefore, a permanent magnet DC motor has a lower induced torque per ampere turns of armature current than a shunt motor of the same rating. There is a risk of demagnetization of the poles which may cause by the large armature current. Demagnetization can also occur due to excessive heating and also when the motor is overheated for a long period of the time. The magnetic field of permanent magnet DC motor is present at all time, even when the motor is not being used. Extra ampere turns cannot be added to reduce the armature reaction. Now we will move to the next topic, introduction of brushless DC motor. So what is brushless DC motor? Brushless DC motor, also known as BLDC motor or BL motor, is an electronically commutated DC motor which does not have brushes. The controller provides pulse of the current to the motor winding which control the speed and torque of the synchronous motor. सिंपल लैंग्वेज में हम बोल सकते हैं ऐसी मशीन जिसमें हम ब्रश यूज नहीं करते, कार्बन ब्रशेस जो कि नॉर्मल डीसी मशीन में यूज होता है, उसको हम बोलते हैं ब्रशलेस डीसी मोटर. So these type of the motor are highly efficient in producing a large amount of the torque over a vast speed range. In brushless motors, permanent magnet rotate around a fixed armature and overcome the problem of connecting current to the armature. Commutation with electronics has a large scope of capabilities and flexibilities. They are known for smooth operation and holding torque when stationary. So next question occurred in our mind, how does a brushless DC motor work? Before explaining the working of a brushless DC motor, it is better to understand the function of brushed motor. In brush motor, there are permanent magnet on the outside and a spinning armature which contain electromagnet is inside. These electromagnets create a magnetic field in the armature when the power is switched on and help to rotate the armature. The brushes change the polarity of the pole to keep the rotation on of the armature. The basic working principle for the brushless or brushed DC motor and for the brushless DC motor are same, that is internal shaft position feedback. Brushless DC motor has only two basic parts, rotor and stator. The rotor is a rotating part and the stator and has a rotor magnets, whereas stator is a stationary part and contains the stator winding. In brushless DC motor, permanent magnets are attached in the rotor and move the electromagnet to the stator. The high power transistors are used to activate electromagnets for the shaft turn. The controller performs power distribution by using a solid state circuit. Next topic is a classification of brushless DC motor. So basically brushless DC motor are of two types. One is outer rotor motor and other is inner rotor motor. The basic difference between the two is only in designing. Their working principle are same. पहला जो हमारा होता है वो इनर रोटर होता है, मतलब रोटर अंदर साइड होता है, जैसा नॉर्मल मशीन में हमारा होता है कि आउटसाइड स्टेटर होता है और इनसाइड रोटर होता है. सेकंड अरेंजमेंट इसमें जो होता है वो आउटर रोटर होता है. इसका मतलब जो रोटर होता है वो आउटर साइड होता है, स्टेटर जो होता है वो इनसाइड होता है. तो ये दो क्लासिफिकेशन है परमानेंट ब्रशलेस डीसी मोटर के, इनर रोटर डिजाइन एज वेल एज द आउटर रोटर डिजाइन. It's called inner rotor design. This is the diagram for inner rotor motor. In inner rotor design, the rotor is located in the center of the motor and the stator winding surrounding the rotor. As the rotor is located in the core, the rotor magnets do not insulate heat inside and heat get dissipated easily. Due to this reason, inner rotor design motor produce a large amount of the torque and widely used. Next is a outer rotor design. So this is a diagram for outer rotor motor. In an outer rotor design, the rotor surrounds the winding which is located in the core of the motor. The magnets in the rotor trap the heat of the motor inside and do not allow to dissipate from the motor. Such type of the design motor operated at lower rated current and has low cogging torque. Next topic is advantages of brushless DC motor. So there is a various advantages of brushless DC motor. Some of them here. Number one, brushless motor are more efficient as its velocity is determined by the frequency at which the current is supplied, not the voltage. As the brushes are absent, the mechanical energy loss due to friction is less, which enhanced the efficiency of the motor. Brushless DC motor can be operated at high speed under any condition. There is no sparking and much less noisy during the operation. More electromagnets could be used on the stator for more precise control. Brushless DC motor accelerate and decelerate easily as they are having low rotor inertia. It is high performance motor that provide large torque per cube inch over a vast speed range. Brushless DC motor do not have brushes, which make it more reliable, high life expectancy and maintenance free operation. There is no ionizing spark from the commutator and the electromagnet interference is also get reduced. Such motors cooled by the conduction and no airflow are required for inside cooling. Some disadvantages of brushless motor is that brushless DC motor cost more than a brushed DC motor. The limited high power could be supplied to brushless DC motor, otherwise too much heat weakens the magnet and the insulation of the winding may get damaged. Now the next topic is a references of this presentation. Thanks to watching this video.